already covered linear functions, how to solve linear equations, and how to write actually system equations, and then how to solve system of equations. We also covered some 3x3 systems as well. So today we want to start with the quadratic function. So guys, in this video I would like to talk about the equations, the three ways of expressing a quadratic equations using the algebraic methods, and then we will also talk briefly about the solutions. What does a solution mean, and how many solutions can a quadratic equation or a quadratic function have? So this video is going to be about that, and then from the next video onwards we'll be talking about solving quadratic equations, and most of the times in these videos we'll be using the algebraic methods. But let us get started with the basic idea of a quadratic function, and then in the next videos we'll start solving. There's so many different examples and there's so many different types of quadratic functions, so it would be fun and interesting to actually look at so many different types. Okay, so guys, there are essentially three different ways of expressing a quadratic function, and all three are important at their own at certain point of time they're all important. Okay, so the first one is called the standard form. The standard form looks like this. So it's the standard form. Standard form. The standard form of a quadratic function looks like this. I have f of x equals to ax squared plus bx plus c. The only thing you have to keep in mind is that the coefficient of x squared, which is a, cannot be equal to 0, and that actually makes sense, because if this a is 0, then this whole term vanishes and you're only left with bx plus c. That would look more like a linear function and not a quadratic function, right? So if I ignore this for a second, then it's like more like y equals to mx plus b, which is a linear function and not a quadratic function. So what makes this a quadratic function is the fact that it has an x squared term. Okay, so that is the standard form of expressing a quadratic function. And let me quickly write an example for this. So let's say we have an example, maybe I'm just coming up with an example, maybe negative 2x squared plus 3x plus 5. So this could be an example of a quadratic function expressed in the standard form. So guys, that is number one, the standard form. Now that's not the only way of expressing a quadratic function. There's other two ways as well. The other one, so let's call this number one. Then the other way is called the factored form. Factored form. And how does a factored form look like? The factored form looks something like this. And maybe in different textbooks it might be slightly different, but mostly it looks like this. There's an x minus x1 as the factored, as the word factored suggested, it's the product of two factors, and x minus x2. Okay. So this is equivalent to this form, but it's a different way of expressing a quadratic function. Now this is my factored form, and for this, let us quickly write an example. Well, let's say we have, I'm going to just make this example. Let's say I have 3x minus 2 times 4x minus 5. Okay, product of two factors, and when we multiply them, or if we distribute them, of course x times x will give us x squared, and 3 times 4 is going to give us 12. So we will have the x squared term because the coefficient is different than 0, so it is still going to be a quadratic function. Okay, then the third one, which is also very useful and important in so many different ways, is called the vertex form. The vertex form. And guys, once we start doing these examples and once we kind of dig deep into the quadratic functions unit, you will be able to see what does the actual vertex form actually mean and where does it come from. Right now in this video, I'm not trying to go into a lot of details. I'm just highlighting the three forms, and then we'll talk about the solution methods, and we will talk about some of the, we'll quickly look at the graphs. Okay. So vertex form looks like this. You have f of x equals to a times x minus h whole square plus k. And this h and k, let's hold on to that. What they actually signify, they have to do something with the vertex. They are basically the coordinates of the vertex, but it will make more sense when we actually do some examples on that, which we will do in the later video. So right now, let us only try to understand and remember the basic three ways of expressing an equation of a quadratic function. And let us look at an example here. We have f of x equals to, let's say we have 3 times, or maybe 3 halves. We can also have fractions, right? And then x minus 2 square plus 5 halves, okay? Yeah, I don't want you guys to think that there's always going to be integer values, guys. There can be fractions, there can be decimals as well. So these are the 3 ways of expressing a quadratic function. Guys, when you think about the solution methods, so here I'm going to talk about looking at the solution method from a visual, a graphical perspective. And then from the next videos, most of the times we will be actually using the algebraic methods for solving a quadratic function, okay? But I want you to understand, what does the solving a quadratic function or a quadratic equation mean in terms of the graphs, okay? So there are 3 possible scenarios here as well. A quadratic equation can have either 2 solutions, actually at most 2 solutions, or it can have 1 solution, and that could be a repeated solution, or it could have basically no solution, okay? These are the 3 possible scenarios. So how do these scenarios look in terms of the graphs? Let us quickly look at that. So number 1, if we have a quadratic function, this is my x-axis, this is my y-axis, and if we have a quadratic function, the graph of a quadratic function is a parabola which either opens up or it opens down, okay? So let's say we have a graph which opens up and which looks something like this, okay? Guys, there is 2 possibilities. One, the graph can open up, the other one is the graph can also open down, okay? Now if it opens up, then these 2 points, now these are very important points in terms of when you are thinking in terms of actually solving a quadratic function. There's actually 3 points. Guys, there's this point as well. But this point is not so important for us right now because we're thinking about the solutions. When it comes to solving a quadratic function, these 2 points are more important because the solution of a quadratic function is the point where the function, where the graph of the function actually touches or intersects the x-axis. So this point and this point, actually the x values for that point, those 2 points actually gives us the solutions for this particular quadratic function. So if this is x1 and this is x2, then x1 and x2 are my solutions. Sometimes people also like to call them as zeros of the function. Other times people also like to use the word roots. Guys, they all mean the same in context to finding the solution for a quadratic function. Okay, so this is the first scenario. When you have a graph which opens up in this case, and it touches the x-axis at 2 points. So if it touches the x-axis at 2 points, how many solutions does the quadratic function have? It has 2 solutions, okay? The second scenario, let us look at the second scenario. In the second scenario, we can have, let's say this is x, this is y. In this case, let us say we have a graph that opens down, okay? So let's say I have a graph which looks like this. So it touches the x-axis only at 1 point, right? It may cross the y-axis here. I'm not really worried about that right now. So if it touches the x-axis only 1 point, then let's say this is x1. So in this case, we have, so here we have, I think we should write that. We have 2 real, of course, 2 real solutions. That is type 1. Then in this case, we have only 1 solution. And sometimes that may be a repeated solution, which we will see again when we actually look at some examples. So here we have 1 real solution. Okay, because we are still looking at these solutions in the real domain, right? Real number domain. Then, and sometimes it could be a repeated root. Then the third scenario, I'm sure you must be already like thinking about what could be the third possible way of expressing or drawing the graph for a quadratic function. One was when it touches the x-axis or crosses the x-axis at 2 points. Second was it only touches the x-axis at 1 point. And then the third would be that it does not actually touch the x-axis. So that would look something like this. And let's say this is my x, this is my y, and then let's say the graph looks something like this. It still touches the y-axis, but it is, as you can see, that it no more touches the x-axis. So guys, when you have something like this, then we can say that we have no solution. But in fact, there is a solution, but that solution is thought of as a complex solution, We're not talking about the complex numbers at this point because I want to start everything in the real number line on the real number domain, and then once we understand all the solution methods, then we can also bring in the complex numbers as well. But here we can simply say that we do not have any we don't have any real solutions. No real solutions. Okay. So guys, at this point, if it crosses or touches at 2 points on the x-axis, 2 solutions, 2 real solutions. If it touches only at 1 point, 1 real solution. And obviously the third possibility is that it may not actually touch the x-axis. So if it does not touch the x-axis, then there's no real solution. And I mean, guys, that is something you again have to do. So if you have a graphing paper, you should try to graph these, or you have a calculator, you can use your graphing calculator to explore more and see whether it touches at 2 points, 1 point, or it does not touch at any point. But for me, in the next videos, I'm going to be mostly talking about the algebraic methods of solving different quadratic functions. And there is so many different types. So I'll break it down and I will try to go over each and every type so that you guys are confident with this whole idea of solving a quadratic function. Because guys, this concept shows up in so many other chapters and in so many other fields as well. So till next time, guys, please take some notes on the basic idea of different types of quadratic functions, and thinking also from a graphical perspective, what does the solution of a quadratic function mean in terms of its graphs. Okay, so I will see you in the next video with so many different types of examples.